Hello, this is Patrick at OneCNC West, and what we're going to do in this training video is start to apply toolpath to our part using OneCNC Mill Advantage. Now, because Mill Advantage provides both 2.5 axis and 3 axis toolpath, we're going to use a 3 axis toolpath to perform the roughing operation. All right, let's get started. I'm going to head over to the Command Manager and select Model Toolpaths. Now, one of the main characteristics of model toolpaths is that you can apply these toolpaths directly to solids and surfaces. So let's start with using Z-Level Rough. I'm going to left click, and the very first dialog box wants us to define a tool. Now, we can define a tool manually, or we can select a tool from the tool library. In this first example, I'm going to create a tool manually. I'm going to say this is going to be in turret position number 1. I've given it an RPM of 4,000, a feed rate of 25 inches a minute, and the plunge feed rate is calculated automatically. And let's take just a second to talk about the difference of these. Feed rate is the feed rate that's used in X and Y. Anytime the tool feeds in Z, it will use this feed rate right here. All right, for the tool type, I'm using an end mill, and of course you can click the little down arrow and select from different tool types, but I'm just using an end mill with an overall length of 1.5 inches. 1.5 inches simply means that the tool sticks out of the holder 1.5 inches. Flute length, that's represented by the gold, that represents the flute length, and then we have our diameter at 625 thousandths. That looks good, so let's click next on that. Now, the next dialog box is the clearances dialog box. This defines our clearance plane. We have a rapid plane, and I have this set at 200 thousandths. That's represented by this red grid. The rapid plane is what the tool uses if it has to wrap it up and move from one position to another position. You can think of the rapid Z plane as the safety plane. Now again, that's represented by the red grid. If I were to type in a bigger value, let's say 500 thousandths, notice how the red grid pops up there. So this dynamic feedback is great. And on top of that, you can actually see the solid model. I'm going to put this back to 200 thousandths. All right, now the plunge clearance, that's where the feed rate's going to start. And at the moment, I have that set at 50 thousandths. That looks good. Let's click next on that. Now, within Mill Advantage, the roughing style provided is traditional. Now, lift between cuts on last depth is going to give you a much better surface finish on the last depth of cut, as the tool will lift as it repositions from one location to the next location. Let's click next on this. For this particular operation, for approach style, I'm going to use ramp zigzag, and I'm going to use the default angle of 3 degrees. I want to spiral inwards, and I want to climb cut. Let's click next on this. Now for step over, I'm using 75% of the tool diameter. If you don't want to use a percentage of the tool diameter, you could uncheck this and then type in an actual amount. For example, let's say 300 thousandths. But for this toolpath, I want to use the percentage of tool diameter. So I'm going to put this back to 75%. Depth of cut, I'm going to have that at 250 thousandths. I'm going to leave 20 thousandths on the side of the part with the default tolerance of 2/10. Let's click next on this. Now, Custom Levels provides the ability to add extra depths of cut to our machining operation. Now, typically you'll probably find that you don't need to add extra depths of cut, but for this part, I do want to use this feature. I want to make sure that I have a depth of cut right at the top of this flange. Now, I know this is at minus 1.125, so I'm going to check Manual, and then here for the level, I'm going to type in minus 1.125 and click Add. So all this is doing is ensuring that at minus 1.125, we're going to have a depth of cut. I think that looks good. Let's click next on that. Now for boundary type, I want to select Picked. That's because I want to pick or select this rectangular boundary that we created in our last video. Now for tool placement, there's 3 options. There's outside a boundary, none, and inside. Now if we were to select outside boundary, that means that the tool will cut outside the boundary until the tool becomes tangent with the boundary. And that's exactly what we're seeing here on this graphic. The black represents the boundary, and the red represents the very center of tool. Now, if we were to use none, that means that OneCNC will take the very center of the tool to the boundary. And again, that's what the graphic is showing us here. We see the red, which represents the center of tool, and we can't see the black boundary because the center of tool and the boundary lie within the same 3D space. Now, if we click inside boundary, that means that OneCNC will keep the tool inside of the boundary until the tool becomes tangent. And again, that's what this graphic represents. Red represents center of tool, black represents the boundary. For our example, let's change this to outside boundary. Now, in the lower right-hand corner, this controls the amount of toolpath along the z-axis. You can think of this as the z-axis envelope. Now, let's explain how this works. If we're going to use automatic Z, we can type in a value, and in this example, there's a default value of 50 thousandths. Now, what happens is OneCNC scans the solid model, or it scans the surfaces, or combination of both, and it's going to add 50 thousandths to that. So in this example, the toolpath will be confined to this Z envelope of minus 10 thousandths for top and minus 1 inch 300 thousandths for the bottom. Now, if I were to change this to 0, that's actually, again, scanning the solid model, and Z-top is showing the exact top of the solid model at minus 60 thousandths, and the bottom of the solid models at minus 1 inch 250 thousandths. Now, you can overwrite that. Let me give you an example. I'm going to uncheck this, and I can type in, for example, 0, and for the bottom, I'm going to type minus 1 inch 300 thousandths. This simply means the toolpath is going to be confined in Z to Z top 0, Z bottom 1 inch 300 thousandths. All right, very good. Let's click Finish. And all we have to do now is select the boundary. So I'm going to left click and then right hand mouse click to let OneCNC generate the toolpath. Now, if we look over here within the NC Manager, you're going to notice our very first toolpath, Z-level rough. Now, why don't we simulate the toolpath? I'm going to right-hand mouse click and select Simulate Rest. Now, within this dialog box, this is where we define the stock. I'm going to be using Pick a Boundary because I want to pick this rectangular boundary that we created earlier for the stock. Over here on the right, this determines the thickness of the stock. If you select Automatic Offset and type in a value, for example, 100 thousandths, OneCNC will scan the toolpath, add 100 thousandths to that, and use that to create the thickness of the stock. For this part, I'm going to leave this unchecked, and I'm going to manually define the thickness of the stock. I'm going to say the top of the stock's at 0, and the bottom of the stock, let's just make that minus 1 inch 500 thousandths. That looks great. Let's click OK. Take our cursor, left click the stock, and right-hand mouse click to see the toolpath simulation. All right, so you can see the tool making the first depth of cut. You can see our stock. In the upper right-hand corner, you can see the location of the tool. You can speed the simulation up by moving this little slider to the right. If you want to slow the simulation down, move the slider to the left. You can also rotate, zoom in and zoom out, and pan if you'd like to during the simulation. It's very nice. All right, so there's our very first toolpath for OneCNC Mill Advantage. Now let's exit out of the toolpath simulation and begin to work on our next machining operation. All right, so let's take a look now at removing material from the very top of the part. To do this, let's head back over to the Command Manager and select Planar Finish Face. Once we do this, we need to select the surfaces that we'd like to machine. All I'm doing is I'm just left-hand mouse clicking the surfaces. And it doesn't matter which order you select the surfaces, just so long as you select the surfaces that you'd like to apply the toolpath. I think that looks good, so let's right-hand mouse click. And just like with our previous machining operation, the very first dialog box is where we need to define a tool. In this example, I have the tool set in turret position number 2. I'm happy with my speeds and feeds. I'm using a ball end mill at 3/8 diameter. This looks good, so let's click Next on that. Our clearance planes look good. I'm going to click next on this. Now we have our planar cut options. The very first thing we need to take a look at is the toolpath angle. That's the angle of the toolpath. Now 0 is going to be parallel to the x-axis. That's exactly what we want. But if we typed in something like 90, that would make the toolpath parallel to the y-axis. Let's leave that set to 0. Our minimum clearance, you can see that represented over here, these little moves in Z. That's a feed rate down. It's a clearance value. It's where the toolpath will start to feed down. 200 thousandths is great. Now leave for finish, I have this set to 0 because I'm considering this a finish pass. And I'm going to use the default tolerance of 2/10. Now for direction, there's 3 different options. There's zigzag, that's simply just back and forth. And also you have climb cut and conventional cut. Let's go ahead and use zigzag for this. I'm going to use constant step over, but I'm going to change the amount to 30 thousandths. That looks good, so let's click next on that. Now for boundary type, I'm going to use part, tool placement set to none, and I'm going to use these default parameters as far as controlling the toolpath in Z. I think all this looks great, so let's click finish. Now if I hit the spacebar twice to go into a CAD view, click on the machining operation, you can see that indeed the toolpath is parallel to the x-axis. Very good. All right, now let's take a look at removing material from the side of the part. Let's head back into the command manager, and this time let's use Z-level finish. And by the way, anytime you see the prefix Z-level in front of a machining operation, for example, Z-level rough, Z-level finish, that simply means that the tool positions itself at the proper Z-level and then performs an XY cut all the way around and then repositions down to the next Z-level and repeats the same process over and over again. So we're going to be using Z-level finish. Let's click on that. We're going to be using the exact same tool we used before. That's that 3/8 diameter ball end mill. All the speeds and feeds look good. Let's click next. Our clearances look great. We'll click next on that. Now for approach style, there's 3 different options. There's vertical approach. That simply means the tool is going to feed straight down in Z, engage the part, and then perform its XY cut. Radial approach means the tool is going to arc onto the part, then perform the cut, and then arc off again. And ramp boundary is a ramp approach. We're going to be using radial approach for this, and I'm going to use a radial radius of 250 thousandths. Now remember, we've already removed material from the very top of the part. So you'll notice that I have this option activated called Pick Faces to Avoid. We don't need to re-machine something that we've already applied toolpath to. We're going to use climb milling. We'll click next on that. I'm going to use a constant depth of cut of 30 thousandths. We'll leave 0 on the side, and then we'll use the default tolerance of 2/10. Let's click next on this. I don't need to add any extra depths of cut, so I'm going to leave this alone and simply click next. Now for boundary type, we're going to use picked, tool placement set to none, and notice how I'm not using automatic Z here. That's because I want the toolpath to stop at -1 inch, 125 thousandths. Let's click finish. Now we're going to select the boundary with the left click and then right click. And now when CNC wants us to select the surfaces we want to ignore, I want to click this surface because we've already machined that. So this toolpath will indeed ignore this surface. Let's right-hand mouse click and let OneCNC generate the toolpath. Hey, I think that looks great. Let's take the toolpath into simulation now. We're going to head back over to the NC Manager, right-click on the toolpath group, and select Simulate Rest. From there, we're going to use Pick a Boundary, and our stock thickness starts at Z0 and stops at Z-1.5 inches. Very good. Let's click OK. Let's left-click our boundary, right-click, and here we go. Here's the roughing operation. Then we're going to switch tools to that 3/8 diameter ball end mill and start removing material from the top of the part. The toolpath is parallel to the x-axis, 30 thousandths step over. During the simulation, you can rotate, you can zoom in and zoom out, and you can also pan. If you hold the control key down on the keyboard while pressing the mouse, the wheel on the mouse, you can pan back and forth. You can also turn the toolpath on by activating backplot. Red represents a rapid move, green represents a feed move. Oh, that's looking really good. All right, that's it for this video. In the next video, we're going to take a look at applying the remaining toolpath. Thanks for watching, and I look forward to seeing you in the next video.